Viewers, once again we are around with construction and logos, and today I want us to look at two other examples of logos. The very first one is circle. It is interesting to note that the circle is the locus of points equidistant from a fixed point. The circle is the locus of points which are equidistant from a fixed point. The fixed point is the center of the circle, and the constant distance is the radius of the circle. So if you look at what I have here, O is the fixed point. OP is the fixed distance. Now, if P is to move so as to be at a constant distance from O, the only way it can move is to describe this circle with OP as center. O is the fixed point, P is a moving point, and the condition is that P has to be at a constant distance from O. The only way it can happen is for you to use O as center and OP as radius and describe a circle. So this circle, this circumference, this circle is the locus of points which are equidistant from a fixed point. So take note that the circle is the locus of points which are equidistant from a fixed point. That fixed point is the center of the circle. That constant distance is the radius of the circle. Now, another type of locus we can look at is the locus of points which are equidistant from a fixed line segment. The locus of points which are equidistant from a fixed line segment. Let us take AB as a fixed line segment here, and we want to construct the locus of points equidistant from AB. Now, the only way we can do it, in fact, that locus has to be a pair. The locus of points which are equidistant from a fixed line segment is a pair of parallel lines on both sides of the fixed line and equidistant from the fixed line. This AB is the fixed line. To construct the locus of points which will be equidistant from AB will be a pair of parallel lines on both sides of that AB and equidistant from AB. So what you do is you take 2 points X and Y equidistant from AB, X and Y equidistant from AB. Then you are now going to construct lines through X and Y parallel to AB. And to do that, you take a point P on AB. Take a point P on AB. Now join XP. When you join XP, you will get angle XPA. XPA. What you need is go to the point X and construct an angle equal and alternate to angle XPA. We have already done constructing or copying an angle. Now, to construct that angle now, you need to use P as your center, and the convenient radius you describe an arc. This way. You go to X, using the same radius, you describe another arc. Then you now come and measure the 2 points at which the first arc cause XP and AP, and with that as your radius, you describe an arc. which will cut this at this point. What I'm saying in effect is that with what we have done so far, you construct angle XPA equal to, let us call this points R and S. Call these points R. Call this point S. So what we have done in effect is to get angle PXR equal and alternate to angle XPA. Please take note. You have been able to construct angle RXP or PXR, this angle, equal and alternate to angle XPA. By so doing, you can see that XR is parallel to AB. Now, similarly, when you construct angle APY equal and alternate to angle PYS equal and alternate to angle APY, it makes YS parallel to AB. So by so doing, we are able to construct parallel lines on both sides of AB and equidistant from AB. So these parallel lines, these two parallel lines on both sides of AB, and which are equidistant from AB, is the locus of points which are equidistant from the fixed line AB. Every point on XR, every point on that XR is, and every point on RS is at a constant distance from AB, from our construction. So XR, YS, these are parallel lines on opposite sides of AB and equidistant from AB. So that is how you can construct the locus of points which are equidistant from a fixed line segment and as a pair of parallel lines on both sides of the fixed line and equidistant from the fixed line. So we shall look at one or two more aspects of construction, but suffice it to say that we have been able to look at 4 types of locus. We saw the locus of points equidistant from 2 lines meeting at a point as the bisector of the angle. The bisector of an angle is the locus of points which are equidistant from the 2 lines that meet at a point. And we use that idea to construct an incircle. We also saw the locus of points equidistant from 2 fixed points. The locus of points equidistant from 2 fixed points is the perpendicular bisector of the line segment joining those 2 points. The perpendicular bisector of the line segment that joins any 2 points is the locus of points that are equidistant from those 2 fixed points. We equally use that idea to construct a second circle. Now, today, we are adding the circle as the locus of points equidistant from a fixed point. And we are looking at a pair of parallel lines on both sides of a given line as the locus of points which are equidistant from the fixed line segment the locus of points which are equidistant from a fixed line segment is a pair of parallel lines on both sides of the fixed line and equidistant from the fixed line. That is the much we shall take on locus for now. Thank you and God bless. Once again, I'm allowed to continue with our work on construction. This time around, I want us to look at the construction of the perpendicular to a line from a point outside it, and the perpendicular to a line from a point on it. Now, in the case of a given line segment AB and a point P outside it, we are required to construct a perpendicular from P to AB. What do? Using P as center and a convenient radius, you describe arcs to cut AB at M and N. That is, with P as center and a convenient radius, you describe arcs or an arc to cut AB at M and N. Now, with M and N as centers, you describe arcs with a convenient radius. You describe arcs to cut each other at the point Q. Let me go over it again. With P as center and a convenient radius, you describe an arc to cut AB at M and N. Then, using M and N as centers and another convenient radius, you describe arcs to cut each other at the point Q. Join PQ. PQ is the required perpendicular to AB through the point P. PQ is the required perpendicular to AB through PQ. Now, in the case of a perpendicular to a line from a point on it, now this time around P is on CD. P is a point on the line segment CD, and we want to construct a perpendicular to CD through the point P. What do? Using that P as your center and any convenient radius, you describe arcs to cut CD at X and Y. With P as center and a convenient radius, you describe arcs to cut CD at X and Y. Now, using X and Y as centers, and another convenient radius, we describe two arcs to cut each other at the point Q. Using X and Y as centers and a convenient radius, you describe arcs to cut each other at the point Q. Join PQ. PQ is the required perpendicular to CD through P, a point on it. PQ is the required perpendicular to CD through P, a point on it. So, We have clearly seen how we can construct a perpendicular to a given line from a point outside the line and from a point on the line. Thank you and God bless.